Okay, class, welcome to Sequences and Series on Chapter 10. So we're going to go through some definitions and then some problems. So a sequence is a function whose domain is the set of consecutive integers, and unless otherwise stated, the domain will start with 1, and the range are the terms. And sequences can either be finite or infinite, infinite meaning going on forever, and finite meaning it ends. For the finite sequence here, 2, 4, 6, 8, the domain is 1, 2, 3, 4, because we have the first term, the second term, the third term, and fourth term. And then remember, the domain is the set of consecutive integers. So the domain would be 1, 2, 3, 4, because the terms are 1, 2, 3, 4 terms. And then the range would be the output, the actual sequence itself. Okay, so for a finite sequence, your n will be your input, your domain, so the first term, second term, third term, fourth term, fifth term, and those can be applied to a function, and your output, or your range, would be 3, 6, 9, 12, 15, for example. Okay, so the domain and the range. So the first term is 3, the second term is 6, and so on. So the domain gives you the position of the term, like the fourth term is 12. And then the range is the actual sequence itself. And so we can write a rule for this finite sequence. So we see that these are all multiples of 3, 3, 6, 9, 12, 15. So to say that it's multiples of 3, we say 3n. And if we plugged in n equals 1, we get 3. So this a sub n notation, it's very similar to kind of like f of x or f of n notation. For example, like if you found f of 1, and your f of n was 3n, it would be 3 times 1, or 3. If you needed to find f of 2, it would be 3 times 2, or 6, the second term. But instead of using this kind of f of x notation, we're using a sub n notation. So we say a sub 1, that's equivalent to f of 1. So the first term is 3 times 1, or 3. A sub 2, the second term, is 3 times 2. We're plugging 2 in and get 6 out. So our n would be the term number, and 3n would be the function. So a sub n is equivalent to f of x or f of n notation. Okay, so here we're going to find the first 4 terms of the sequence. So here we're given this sequence, and we need to find the first 4 terms. So the first 4 terms would be n equals 1, 2, 3, and 4. So we're going to find a sub 1. Subscript 1, meaning plug in n equals 1. Okay, so this is minus 1/3 to the 1 minus 1, 0. Minus 1/3 to the 0 is 1. A sub 2, so now we're plugging in n equals 2. So it's minus 1/3 to the 1 power, because 2 minus 1 is 1. Minus 1/3. A sub 3, the third term, so we plug in n equals 3. So it's minus 1/3 squared, which is minus 1/3 times minus 1/3, which is a positive 1/9. And for the fourth term, we're going to do minus 1/3 cubed, which is minus 1/3 times minus 1/3 times minus 1/3, which is minus 1 over 27. For the first 4 terms are 1, minus 1/3, 1/9, and minus 1 over 27. So the first 4 terms of the sequence. Since it is a sequence, we write it separated by commas in a list of numbers. So here we want to find the 13th term of the sequence. So here this tells me that n is 13. So we're going to find a sub 13, which is 13 over 13 plus 1. So my n is 13, so I'm just replacing my n with 13. So it's 13 over 14 would be the 13th term of the sequence. Okay. So here we're going to describe the pattern and write the next term and write the rule for the nth term. Okay, so describe the pattern. So I see 2's on top. That's the pattern on the top. On the bottom, 5, 25, 125. Well, this is 5 to the first power. This is 5 squared. This is 5 cubed. The first term would be to the first power. The second term to the second power. The third term to the third power. So it's 5 cubed. In words, we would say it's 2 over a power of 5. Okay, but that's really the pattern that we're going to look for. The next term, well, it's going to be 2 over 5, well, it's 5 to the 1, 2, 3, 5 to the 4th. So it's 2 over 5 to the 4th. In general, the nth term, it's 2 over 5 to what power? Well, the first term, when n equals 1, it was 1. When n equals 2, the exponent is 2. When n equals 3, the exponent is 3. So it's 5 to the nth. So that would be the rule, the a sub n term. So a sub n equals that. Okay, so the next one, we're going to look for a pattern 3, 5, 7. Well, you could say it's all odd numbers. Okay, so we're going to try and find a pattern. Okay, so to get all odd numbers, in general, the way you're going to get odd numbers is similar to the way you can get even numbers. It's pretty easy to know that 2n is all even numbers. So if I plug in n equals 1, remember my domain is n equals 1, 2, 3, and 4, and then this would be my range. When I plug in n equals 1, if I were to plug it into here, I would get 2 out. This number is 1 more than that. If I plug in n equals 2 into my pattern, I get 4, but I want 1 more than that. So it's 2n plus 1. So to get evens, it's always going to be 2n. To get odds, it's either going to be 2n plus 1 or 2n minus 1, or some variety of that, depending on where you wanted to start. If I wanted to start instead, like with 1, I would have been 2n minus 1, because if I plugged in n equals 1, I get 2 out, and I don't want to subtract 1 to get my 1. Okay, so evens, it's like 2n, odd is 2n plus 1, 2n minus 1 would be the general rule. So that actually is the a sub n term, 2n plus 1, and the next term would be 11, following the pattern of odd numbers. Okay, so here we're going to find the first 4 terms of the recursive sequence. So a recursive sequence is a sequence that's defined using the previous sequence. Okay, so we're going to, in order to find a2, we have to know what a1 is. In order to find a3, we have to know what a2 is. And to find a2, we have to know what a1 is. So in order to find the next term, you use the previous term. Okay, so instead of n, recursive uses k, but it's just like a sub n. So if a sub 1 is 2, we use this information to find the second term, right? The first term is 2. That's what that tells. A sub k plus 1. That's the next term. Okay, after the kth term, the k plus 1 term. Okay, so to find the next term, the one after the kth term, the k plus 1 term, it's 3 times that term plus 1. Okay, so let's just say k equals 1. Okay, because that's what this first one is. K equals 1, we get it equals 2. A sub k plus 1 equals 3a sub k plus 1. So we're going to plug in k equals 1. Okay, so I'm going to plug in k equals 1. So a sub 2 is 3 times a sub 1 plus 1. So to find the second term, you use the term before it, the first term. So a sub 2 is 3 times, well, what's a sub 1? That was given to us as 2 plus 1, or 7. Okay, so now we did k equals 1. Now we're going to do k equals 2. To find a sub k equals 2, so plug it in, the third term, a sub 3, it's 3 times the previous term, the one before 3, which would be 2, plugging in k equals 2, a sub 2 plus 1. So a sub 3 is 3 times a sub 2, which is 7, plus 1, or 22. Okay, so we have the first term, the second term, the third term. So we want to find the first 4 terms. We're going to find the fourth term, a sub 4, is 3 times the previous term plus 1, which is 3 times 22 plus 1, because the previous term was 22. 66 plus 1 is 67. So the first 4 terms of a sequence, which is written as a list, would be 2, 7, 22. This is 66 plus 1 is 67. 67. Those would be the first 4 terms of the sequence. 1, 2, 3, and 4. Okay, same idea with the second one. The first term is 25. To find the next term, the k plus 1, it's the first term minus 5. So a sub 2 would be 25 minus 5, which is 20. A sub 3 would be the previous term minus 5, which is 15. A sub 4 is the previous term minus 5, which is 10. So the first 4 sequence is 25, 20, 15, and 10. And pay close attention to the question where it says find the first 4 terms or the next 4 terms. So the first 4 terms would be A1 through A4. If you were given A1 and you're asked to find the next 4 terms, then you'd have to find 2, 3, 4, and 5. Okay, so that is recursive sequence. Describe the pattern and write the rule for the nth term. So we have minus 1/3, positive 1/9, negative 1/27, 1/8 So we have powers of 3 on the bottom, 1's on the top, and it alternates between pluses and minuses. That would be the pattern. We have 3 to the 1, 3 squared, 3 cubed, 3 to the 4th. Okay, we have 1's on top. But we have this alternating signs. Okay. So for our input, our n's, 1, 2, 3, 4, first, second, third, fourth terms, these are our terms. We list them out. So can we write them all to some power? Well, we can. This is minus 1/3 to the first power, minus 1/3 squared, minus 1/3 cubed, minus 1/3 to the 4th, because remember, if it's an even exponent with the negative, it comes out positive, and so on. So we can find the next term, which would be minus 1/3 to the 5th, and in general, we can write the nth term rule for this, which is a sub n equals 1/3 negative 1/3 to the nth power. Okay, so the reason that is because our pattern was it's 1/3 to minus 1/3 to some power. The first term had an exponent of 1, the second term had an exponent of 2, the third term had an exponent of 3, and so on. Okay, so let's move on to the next slide. Sequences and series using sigma notation. Okay, sigma, this is a Greek letter, or summation notation. So sigma or summation notation. So a sequence, remember, is a list of numbers separated by commas, and if you add them up, you get what's called a series, and a series can be infinite or finite. So finite sequences end, and then you can take, if you add up the terms in a sequence, you get what's called a series. So you can have them finite, or you can have them go on forever and infinite. So we can use summation notation to write these series. So for these ones where you want to add up 3, 6, 9, 12, 15, we can rewrite it using sigma notation, and sigma means sum or add up. So let me slide this down. So we can do the summation notation. So this long thing written out, 3, 6, 9, 12, 15, can be rewritten as the sum of 3i or 3n. You could use whatever letter you want, I or m. It's just an indexing letter. Because remember, the pattern for this was 3n or 3i, because the first term was 3, the second term was 3 times 2, the third term was 3 times 3, 3 times 4, 3 times 5. So we are going to start adding the terms at I equals 1. So we're going to take 3i, we're going to plug in I equals 1, get 3 out. And the pattern rule is always what goes on this side of the sigma, and then the top number is where we stop adding. So we're going to add up all the numbers. Plug in I equals 1 all the way to I equals 5. So plug in I equals 1, you get out 3. Plug in I equals 2, I equals 3, I equals 4, I equals 5, and add those up, and that's your answer. So if you were asked to find this in sigma notation, you would write the list 3, 6, 9, 12, 15, and add up those terms, and that would be the sum. Okay, so we're going to do some practice problems with these. Okay, so I think we're going to get cut off with time, so I will do these problems on the next video that you need to watch. Thanks.